Okay, can you guys hear me now? Yeah, there we go. We've got sound now. Okay, so I think we have sound. So if you can just let me know in the comments if we have sound or not. And then we can get started in a couple of minutes. We can just wait for the rest to join in. I don't know why the camera quality is so bad though. Let me have a look here. Maybe I can change it a bit. There we go. That seems a little bit better. And if I go one more. No, I like that one. Okay, all right. So sound verified. Thank you very much. Okay, so we can get started. Sorry about the delay. I haven't done this in a while, so just had to catch up on things. So let me swap this. There we go. Now there's sound. Okay, so it's using that microphone and not that microphone. So it's using this one's microphone. Okay, all right, not a problem. Okay, so I ran a poll in the previous one, so let me just do that again. I think it was question 1. Where what's this? Answer viewers' questions live. Engage with the audience. Okay, let's start a poll. I think it was question. Let's see. We're doing question 1. It was question 5, I think. Let me just have a look at the past paper that I have open. So question 5 is looking at functions. Yeah, we can have a look at question 5. I'll tell you guys what paper I'm looking at the moment. Question 8 is a good one because that's got to do with your derivatives. And then let's have a look. Yeah, okay, so I will put the link into the description now for where you can get the paper that I'm looking at. But if it has me, question 2, let's add another one, question 2. Okay. So let's just put the link into everyone can access the link as well. Okay, and at the moment I'm going to start with the Gauteng Department Preparation Exam of 2021. Okay, so I think let's jump into that one. So we're doing Gauteng Prep Exam of 2021, and this is Maths 1. Okay, so I think that's what we are going to look at first. Question 5. Okay. All right. We might go straight to question 5 then, because by the looks of it, we have someone asking about question 5. So then let's do question 5. Okay, so let's start with question 5 then. So if everyone can get the question paper, or I can write down the questions that they are asking us, and then we can have a look at it. Probably should have printed the question, to be dead honest. But the link is in the chat section, so if you want to go follow along with the paper, you're more than welcome to. Okay, so question 5, okay, it gives us the following. We are given f of x equals to minus ax squared plus bx plus 6, okay? And then it says 5.1 says if we are given, so it says the gradient of the tangent of the graph at point -1 and 7/2 is 3. Show that a is a half and b is 2. Okay, so we got to find a and b, given that the gradient at -1 and 7/2 is 3. Okay, so what does that mean? Let's break down this first part here and just see exactly what we're looking at. Yep. So first of all, we should recognize that if we take df of x dx, it is equal to the gradient. Okay, so it's equal to m, which should equal to 3. Okay, plus we have a coordinate. So we have an x value and we have a y value. Okay, so we can then solve the question. So let's do the derivative of f. So we want to find f prime of x, which is going to equal to -2ax plus b. Okay, so now this here is my derivative, which equals my gradient. To rotate the screen, it's mirrored. Okay, I understand. Okay, so let me have a look at that. There we go. Let me know if that is better. I keep forgetting that on my side it should be mirrored. So let me know if you can see the paper better. Okay, so just to continue, so we have this is equal to my gradient. My gradient is 3, so we have this function should be equal to 3. So therefore, I have 3 equals to -2a, and then they gave me an x coordinate over here, okay, and a y coordinate. So we can then go and solve this. Okay. Let me just check something quickly. Okay, so the important thing is to realize that we've been given a coordinate that lies on the line for the tangent. Okay, we've also been given the gradient over here, which allows us then to solve for this. So we've got a coordinate. So if we look at this function, essentially, if we look at -1 and 7/2, so let's see what's our function going to look like. It's going to look something like that. Why? Because a is a negative value. Okay, and then we have +6, so we have +6 over here. So essentially what we're doing is we're looking at a point somewhere over there. Okay, and now what we're doing is we're looking at the tangent line which runs over there. Okay, so we have this tangent line here. So we can see that the tangent line, okay, as the question states, is always going to lie on my function. So they're going to be sharing that point. So if I had to zoom in here, okay, over there, we would have the curve sitting here, that point, and then the line running there. So you can see that they're both sharing that point over there. And that coordinate's -1 and 7/2. Okay, so the first thing we can do, sorry, we're not going to equal that to 3 because we want to find the gradient. So what we're going to do is we're going to substitute in, no, that is equal to 3. Sorry, I'm losing my marbles here today. So that's equal to 3. when we're at -1. So essentially we have at f of -1 equals to 3, which then equals to -2a plus b. So we have our first expression, which means we'll have 3, where are we? 3 plus 2a equals b. Okay, so we'll have an expression like that. And then we have a coordinate as well, so we can go substitute that. Oh, that's right. When we substitute the -1 into the x place, that becomes a plus, which means this becomes a minus. Okay, so when we substitute now these coordinates back into my original function, I'm going to have f of -1 equals to, let's see, that's going to be -a times -1 squared plus b times -1 plus 6, but we know that this is 7/2. Okay, let me just move that up. So 7/2 equals then to -a. Remember, we're squaring the -1, so that just stays -a plus, sorry, not plus, minus b plus 6. Okay, now we're going to go check what 7/2 minus 6 is. So if I find my calculator quickly, no, that's not a calculator. Oh, come on. I thought I had my calculator here. Let me just have a look. Okay, so we can do this the long way. That's going to be 12/2. So 7 minus 12 is 5. So we're going to end up with 5/2 on this side equals to -a minus b. Yeah, there we go. Okay, but we know b's value now. It's 3 minus 2a. So essentially we then have 5/2 equals to minus a, then minus 3 minus 2a. Okay, and if we sort out our numbers over here, let's see, that's going to be a plus. So we're going to have an a on this side. We take that over, it becomes minus 3. Take it becomes plus. So you're going to end up with a is going to equal to, let's see, that 3 goes over, 5/2 plus 3 gives you 6. You're going to end up with 2. Okay, so a half. So a is going to be a half, okay, and then we just substitute that back in here. So then we have 3 minus 2 times a half equals b, and then we get b equals to 2. Okay, so there we've got those values and we've solved for a and b. Okay, so the next question then says calculate the x-intercepts of f. Okay, so that's pretty straightforward. We've now got the function. So 5.2, we want x-intercepts. Okay, so now that we have that over there, we have the following function, f of x equals to, a was a half, so minus a half x squared plus 2x plus 6. Okay, so what I'm going to do is to make life easy, we want the x-intercepts. So we're going to set this equal to 0. So equals to -1/2 x squared plus 2x plus 6. I'm going to divide out, multiply out by, so I'm going to have 0 equals to x squared, then this becomes minus 4x, and then that becomes minus 12, and then we can now factorize that, so 0 equals, let's see, we're going to have 2 brackets, and then we need 12, so that's going to be 6 and 2. My factors are 6 and 2, so to get -4, I'm going to have x minus 6x plus 2. Aha, so we have our x coordinates of x equals to 6 or x equals minus 2. Okay, so this thing's actually sitting more somewhere like that. Okay, all right. The next one then says calculate the coordinate of the turning point of f. Okay, so finding the turning point. Okay, so I'm just going to rewrite my function over here. So that's 5.3. So 5.3 says turning point of f, given that f of x equals to, it was -1/2 x squared, then plus 2x plus 6. Okay, so there's two ways we can do this. You need to be able to do both ways. So number one is using the turning point for the x coordinate equals to negative b over 2a. Okay, we have the b value, we have the a value, and then what you do is you go and find f of negative b over 2a. So there's the first way. The second way, if you're a little bit more courageous to try it, we can take the first derivative, so f prime of x, and we set that equal to 0. Why? Because if we look at our function, the derivative of the turning point is a flat line, which means your gradient is 0. Okay, if we, let's do option 1. It is normally easier. So turning point of x is then going to equal to negative b, which is 2 over 2 times negative a half. So we're just going to end up with an x coordinate of, let's see, that becomes negative 1. So that equals to 2. And therefore we want f of 2, which equals minus a half, 2 squared plus 2 times 2 plus 6. Okay, so let's see what we have here. That's 4. So that becomes negative 2 plus 4 plus 6. So that's 10 minus 2 is going to give me 8. Okay, so therefore I have my turning point. Yes, that makes sense. So my turning point is at the following coordinate, 2 and 8. Okay, if you check your derivative, you'll find out that you end up with the same thing over there. Okay, so if we take the derivative of that, then we get the following. So then we get negative x plus 2 equals to 0. So therefore we have x equals to 2, because if you take that over, bottom here becomes negative, divide up by negative, or if you just take the x across and we get that, and then if you plug that back in here, you see you get the same thing. Hi Mokwena, I think that's how you say your name. I might just use the other part, Richard, because it's easier to pronounce. So I hope all the studying's going well. I hope you guys are feeling confident for tomorrow. Okay. Don't feel scared about the paper. Make sure you get enough sleep tonight. Okay. Don't sit up until 3 o'clock in the morning. You think better on a good night's sleep. Okay. Anyway, so 5.3, we've calculated another turning point of f given our function over here. Okay. So for those who have just joined, we are doing question 5. Where's the page of the Gauteng prep exam 2021? Okay, so Gauteng prep exam 2021. Yeah. Okay, cool. So we've got that. The next one says sketch a graph of f. In your answer book, clearly indicate all the intercepts with the axes. Okay, so that's pretty straightforward. I'm just going to do a rough sketch here at the bottom. That's not too difficult. Okay, so we're sketching a graph. We can see that it cuts at 6 in the y-axis. We said that the x-intercepts were at, if memory serves me correct, it's minus 2 and 0. Minus 2, then 6 over here. We have the turning point sitting at 2, and up here at 8. So there's my turning point. We can see it's a negative a value, so it's a sad parabola. So I'm going to have something like this, and it's going to come down like that. Okay, and then my turning point here is 2 and 8. My y-intercept and my 2 x-intercepts. Okay, all right, so you can see it's going to have a positive turning point over here. Or maximum value is going to be positive. Remember, if you look at its domain and range, its range goes from negative infinity up to 8. Okay, and we always include 8 because it turns at 8. Just for interest's sake. Okay, then it says determine or use the graph and determine the value of x for which f of x is greater than 6. Determine the values of x for when f of x is greater than 6. Okay, so essentially what they're doing there is, if they ask where is the function, so where is f of x greater than 6? Okay, note it's strictly greater, so your x interval, so you're going to say x is an element, and you're going to have round brackets. Why? Because it's strictly greater. So if we look at our graph over here, okay, what I'd like to do is 6 is my y value I'm looking at. So where is the function bigger than 6? So what we do is if we draw a dotted line at 6, cuts across like this. Okay, now essentially we've got to go and find this coordinate over here, and we've got this coordinate, this one's 0. So we need to now go find its opposite one over there. So how would we do that? Essentially what you would do is you would then go and either plug it into the equation, or because this thing is symmetric, you can see 2 units this way means we're at 0, so therefore 2 units this way means we're going to be at 4. Okay, just reading your graph over there. So that should be 4 and 6. Okay, and if you plug in 4 into your equation here, you should get 6 as your output. So let's see, 4 squared is 16. 16 divided by 2 is 8. 2 times 4 is 8. So yes, that cancels out, we're at 6. Okay, all right. So we can see that in this interval, if I go and put my hand there now, okay, where is that function above 6? We can see it's from this point here, which is my y-axis, up to this point here. So where is it above? Okay, so my x interval is going to be from 0 to 4. And we don't include it. Why? Because it asks for strictly greater than. Okay, then it asks, sketch the graph of g of x. Okay, so now we're going to sketch g of x, which equals to minus x minus 1 on the same set of axes of the graph f in question 5.4. Clearly indicate all of those intercepts. Okay, so we've got a negative gradient, and it cuts the y-axis at negative 1. Okay, so essentially here's negative 1. It's got a negative gradient, so where's it going to cut the x-axis? So we make this equal to 0. So therefore we have 0 equals negative x minus 1. So therefore x equals minus 1. Okay, so here at minus 1. Okay, this thing's not drawn to scale. So we're going to have a line that runs something like that, and that's g of x. Okay. The reason why we need this is because the next question says, where is f of x times g of x less than or equal to 0? Okay, now I do know that this often stumps a few students, where we want to know f of x times g of x less than 0. So what does that essentially mean? I need a value less than 0, which means my output needs to be negative. Okay, because if we look at a number line, if you have 0, if I'm less than 0, I'm negative. There's negative 1, negative 2. So I need the product of f and g to be negative. So therefore, one of them has to be positive, and the other one needs to be negative. Or this one needs to be negative, and this one needs to be positive. So what does that essentially mean? It means that if f of x is above the x-axis, okay, then g of x needs to be below the x-axis, because then I need a negative point and a positive point. Or if f of x is below the x-axis, I need g of x to be... Okay, sorry about that. I think I'm experiencing load shedding. So internet's just dropped. Okay, I think everything's fine. Okay, there we go. So it's asking where is one of them negative and where is one of them positive. Okay, so let's have a look here. If we follow this graph here and this graph here, okay, because they're gone forever, which means they tend out to negative infinity here. So you can see from negative infinity, okay, this one, or g of x is positive, f of x is negative. So positive times a negative is going to give me a negative. Positive times negative. So you can see this is happening up until we get to this point here. Okay, so that point over there is what we essentially need to find. Okay, and then what happens again? Now, oh, sorry, not that point there. Up until this point here. Okay, why? Because at this point here that I marked, both of them are above the x-axis. Okay, so if I bring that closer, okay, if you look here at negative 2, we then 0. Okay, which means 0 times this part here is going to be 0. Okay, so up until this point here, everything from negative infinity up until negative 2, this is happy. Okay, now let's have a look. Yeah, everything is above. Okay, so between negative 2 and negative 1, everything is above the x-axis, so that's not going to work because it's positive times positive. Then from negative 1, yeah, let's have a look. Negative 1, okay, we then have negative values and positive values. Aha. So what does that mean? I'm satisfying this again. Okay. This is going to continue on for forever. They will intercept somewhere down here, but let's have a look at. This is all positive values up until I get to 6. After 6, then f of x becomes negative and g of x is negative, which means this becomes a positive. So my two intervals for this, okay, is going to be, the first interval is x as an element from negative infinity up until negative 2, okay. Then because we're moving into the next interval, it's union negative 1 all the way up to negative 6, positive 6. Okay. Why? Because after positive 6, and that's going to be inclusive, this is also going to be inclusive. That's inclusive and that is inclusive. Why? Because they asked for less than or equal to. Okay. So it's important that you can draw the graph and you can interpret what is happening. Okay. If you can't interpret what's happening, or if you can't draw the graphs, you're going to be stuck for a question like this. But the important thing is we're essentially looking, where is one of them positive, meaning where are they above the x-axis, and where is the other one negative, below the x-axis. And if I multiply, if I pick any 2 points that are in the same line, so this point and that point, this is positive, that's negative, therefore multiply them will definitely be less than 0. Okay. Does anyone have questions on this question? Or can I move on? So I'll give it a few more seconds. I do know that these kind of questions here, especially f of x times g of x, less than or equal to 0 or greater than or equal to 0, I do know that some students do tend to struggle with that a bit. Okay. All right. Let's pick another random paper. So let's pick a 2022 paper. So let's go. I'm not going to do any question ones from any of the 2022 papers because I did that. There's an entire video where I covered all the question ones from that. So I know Eastern Cape always has a good paper. If you want to practice difficult questions, Eastern Cape normally has quite a few difficult questions in them. Okay. Okay, so I'm going to now look at the Eastern Cape paper. So we're going to have a look at the Eastern Cape 2022 September paper. Okay, so if you don't have the paper and you want it, then just click on the link in the chat and you can then navigate to just navigate to the 2022 Eastern Cape mock paper. September, so this is the mock exam. Okay, and then you can just open up the mock exam. And then I think for the mock exam, let's have a look. I've done question 1. Any specific section that someone wants me to cover out of the paper? Because remember, your paper is always going to be, question 1 is always going to be solved for x. Question 2 is always sequences and series. Question 3 is also sequences and series. Question 4 starts with graphs. Okay, it's normally your hyperbolas. Then question 5 is always exponential or logarithmic. Question 6 is then functions, parabolas, straight lines, things like that. Question 7, financial maths. Question 8, derivatives. Question 9, implementing calculus. And then question 10, probability. Or it is an optimization question, and then question 11 becomes probability and that. So Let me know what you think or what you want to do. My favorite section is functions. I think that's probably one of my favorite sections. So if you want me to do another functions question, then let me know, please. Otherwise, let me know what section of the paper I must do from the Eastern Cape 2022 mock exam. I should probably learn how to use something like OBS, one of those streaming systems, and I can have more things displayed on the screen. Okay, so let's do a Okay, let's do sequences in series. I'm going to do question two of the Eastern Cape 2022 mock exam. Okay, so that's what I'm going to be looking at now. So it says an arithmetic sequence. Aha, so the first thing we pull out, 2.1. Okay, so 2.1. Okay, so the first thing we read there is we have an arithmetic series. Okay, it has a common difference of 4. Okay, which means we have Tn equals to, what's that? It's A plus N minus 1 times D. Yep. If I can remember correct, if I just look at the formula sheet quickly. I'm just pulling this from memory. Okay, so let me just get the formula sheet here. Yeah. Okay, so we have A plus N minus 1 times D. Okay, and then so they give you that. Then they say that we have 3x minus 1, okay, and 2x plus 8 are the 4th and 7th term in the series, respectively. So this is the 4th, and this is the 7th term. Okay. And it says determine the value of x. Okay. So now we need to go and find the value of x. And note that it's only 3 marks. Yeah, let me just read that again. Okay, so it says the 4th and the 7th term, respectively. Okay, so let's have a look at this. That's actually quite a nice question. So we have 1, 2, 3, 4, 5, 6, 7. Okay, so this is the 7th term, and this one is the 4th term. Okay, so we know that the difference between any 2 consecutive terms is 4. Okay, now, because it's constant, if I go from year to year, I'm plussing 4. If I go from year to year, I add 4. And from year to year, I add 4. Okay, which means now, if I want to solve for x, essentially I want to take the difference between the 7th and the 4th placement. Essentially what you want to say is the 7th minus the 4th. Okay, that should be the 7th, but anyway. And that is equal to, let's see, it's 1, 2, so it's 3 spots times the common difference. Okay, so now we'll solve for x. So we just go and substitute it in. So the 7th term is 2x plus 8. minus, okay, don't forget your brackets for the second term because you have to distribute that negative. 3x minus 1, which then equals to 3 times your common difference, which is 4. Okay, so now we can just solve. We've only got one variable. So I think the difficult part here is just setting this up. Okay, it's just knowing that if I say this term minus that term, I then count the terms between them and multiply them by my common difference. If they gave you the 50th term and the 10th term, we know that there's 40 terms between it, so then this would have been 40 times your common difference. Okay, so let's have a look there. So that's 2x plus 8 minus 3x plus 1 equals 12. So that minus that gives you minus x. That plus that is plus 9 equals to 12. So therefore minus x equals to 12 minus 9 gives you 3. So x equals minus 3. Okay. So yeah, there we go. So we get minus 3. Yeah, so it's actually a really nice question. Once again, Eastern Cape paper never fails with asking interesting questions like this. Okay, then that's 2.1.1. Now let's have a look at 2.1.2. Okay, so it says calculate the first term of the series. Okay, so what we can do is we can do it the long way around. So we can say, well, the fourth term is then equivalent to 3 times negative 3 plus 1. This is the fourth, which means it is then, let's see, that's minus 9 plus 1, that's minus 8. So that's the fourth term. Then we can find the third term, the second term, and the first term by minus 4, minus 4, minus 4. Okay, but only if you're really, really stuck do I suggest then doing that. Okay, otherwise, what should we rather do? Use a formula. Why? Because we have a formula. And then we've got D, we've got N, we've got the output, so we can solve for A. Because A is always your first term. Remember, in Tn equals to A plus N minus 1 times D. This is always the first term of series. Okay, so that's what's squashed up there, but that's always the first term because you need to know where we're starting from, where are we adding and subtracting onto. Okay, so let's use the fourth term. So because we've now got the fourth term, so the fourth term equals minus 8. Okay, we know that N is now 4. We've got D equals to 4 as well, so therefore we can go and solve for A. Okay, so we have minus 8 equals to A plus 4 minus 1 times the common difference, which is 4. Okay, so therefore minus 8 equals A. Let's see that. That's 3 times 4, that's plus 12. Okay, take that over, so with minus 8 minus 12 equals A, and then we get 20. Minus 20 equals A. Okay, let me just double check myself here, make sure I'm not talking nonsense. I'm talking nonsense. What have I messed up? The fourth term, did I say plus 1? Why did I say plus 1? It should be minus 1. See, so I can't even read numbers tonight. So that must be a minus 1, which means this is minus 10. Okay. Therefore, this here should be minus 10. Okay. Even though I make mistakes with numbers sometimes. Okay. So then this here is minus 10, minus 10, minus 10. So this becomes minus 22 equals A. Okay. So you could have done it with the seventh term as well. If you go and calculate the seventh term, it would have been 2 times x, which is minus 3, plus 8. So therefore, that's minus 6 plus 8, which then gives you 2. And then if you then say 2 equals A plus 7 minus 1 times 4, you'll end up with A equal 22 as well. Minus 22. Okay. So you can go check that one if you think my maths is crazy. Okay, so let's have a look then at the next question. Okay, so the next question says, part B, the sum of the first 42 terms in the series. Aha, so we look for the sum. Okay, so what they want is the sum of Tn, okay, so segment notation from 1 to 42. Okay, but now there's a formula for that, so we don't have to add everything up. If you don't know the formula or you don't know how to use it, then yes, by all means, go and add everything up. Okay, but I suggest you use the formula. So Sn equals to A over 2. Is it A over 2? No, it's N over 2. Let's just double check. There we go, N over 2. Okay, so it's N over 2, 2A plus N minus 1 times your common difference. Okay, so N divided by 2, and then you multiply A by 2 as well. Okay, so now we want the S to the first 42 terms. Okay, so what's it going to equal? 42 divided by 2. 2 times your first term, which is negative 22. Okay, plus then N in this case is 42. Minus 1 times your common difference, which is 4. Okay, and you then plug that into your calculator. The thing that I don't have right now for some unexplainable reason. Okay, let me check. I checked. Aha. Yeah, so we plug that into our calculator. So 42 over 2. Okay, please just use brackets so that you don't mess anything up. Open bracket, 2 times negative 2. Oh, and please use that as your negative sign. Don't use the minus. Okay, plus 42 minus 1. And then we times that by 4. Close everything, so you should get an answer of 3. Aha, see, I've made a mistake somewhere. It's when putting in my numbers over here. That. So look. Minus 22, not minus 2. So minus 22, and you get 2520, which is the answer. 2520. Okay, so that's the sum of your first set of first 42 terms. Okay. All right. Then let's have a look at the next one. So 2.2. Okay, so for those of you who have joined, we're doing Eastern Cape 2022 September mock paper, and I'm busy with question 2, sequences and series. Okay, so I think I'll just write that on every page so that everyone has, so those who join can always see what we're doing. Okay, so this is Eastern Cape 2022 mock exam. Okay, and we can find this on the website test papers. Okay, so shout out to them for always putting up all our exams. Okay, so 2.2 says the first term of a quadratic number pattern is 61. Okay, so we're dealing with quadratic. Okay, so this is 2.2. So we're dealing with quadratic, and T1 equals to 61. Then they tell you that T of K equals to 4K minus 26 forms the first difference of the quadratic number pattern. Aha, so this is your first difference. Okay, so essentially what does that mean? So we're going to have 61 and another term and another term and another term and another term. Okay, so this difference here follows this function over here. Okay, so if we want the second term, so if we want, okay, so T1, T2, T3, T4, oh sorry, not T4, go. So this is T1, T2, T3, T4. So we can then just go substitute that in. Okay, so let's have a look there. For the first term over here, we can say 4 times 1 minus 26 gives us minus 22. So minus 22. Okay, what are we noticing? Minus 22, let's go back to our previous question. Bingo, our first term in 2.1 was minus 22. And then we added 4, so that became minus 18. We added 4 again, so that's minus 14, yada, yada, yada. Okay, so let's see what happens if we end up with the same thing over here. I'm going to keep this one over here. Okay, let's have a look there. So now if I say 4 times 2 minus 26, minus 18. And then if I say 3 minus 14, so it's following the exact same pattern we had in question 2.1. Okay, so essentially we're saying 61 minus 22 is going to give me 39. Okay, then we are minusing 18, so answer minus 18, which gives you 21. Okay, minus 14 gives you 7. Okay, so that's essentially our number pattern over there that's starting. Okay, then we have all that. Then it says write down the second and third term of the quadratic number pattern. Ta-da, there we go, we've done it. So we found that T1 equals 2 minus 22. So then we minus that off. We found T2 equals to minus 18. We minus that off over there. So we found the second and the third term in the quadratic number pattern. Then it says, so this would be 2.2.2. Okay, so 2.2.2 then asks you, if the nth term of the quadratic number pattern is given by, so they give you the number pattern, that's very nice, Tn equals 2n squared minus 28n plus 87, okay? Calculate the value of the smallest term. So we need to find the smallest term of this. Okay, now remember, it follows a quadratic number pattern. So what does that mean? Okay, well, quadratic, n squared, this is essentially ax squared plus bx plus c. We know that it is a positive one, so therefore it's going to be a happy parabola. Okay, so we want to find the smallest possible value. What is the smallest, the turning point, essentially? Okay, so that's what you're finding. You're finding the turning point. Okay, and as I said in the previous question, there are 2 ways to find the turning point that you should know off by heart. Okay, so smallest value equals turning point. Okay, so let's go over it again. One is you use the formula given to you. TP equals to negative b over 2a. Okay, does everyone know where this comes from? Okay, just for a quick explanation, where this comes from. Negative b over 2a comes from your quadratic formula. So negative b plus minus the square root of b squared minus 4ac all over 2a. Okay, now, if this, if your square root is equal to 0, it means what? It means that you're on the axis of symmetry of your hyperbola. Okay, it means we haven't deviated to the right or to the left of my axis of symmetry when this here equals to 0. So when this equals to 0, we're at my axis of symmetry, which means it will always give me my turning point. Okay, because axis of symmetry is always turning point, so this here goes to 0, and then you end up with your turning point. Okay, so if we substitute our values in there, negative or b's value, a's value, and c's value. Okay, so therefore we have negative 28 divided by 2 times 2, which is equal to, sorry, I just had a brain lag. So that is 28 divided by 4, 7, 14, 21, 28. So it's 7. Okay, now we substitute that back in. So essentially we're looking for the 7th term. So 2 times 7 squared minus 28 times 7 plus 87, which is that's a big number. I can't do that in my head. So pull out the calculator. 2 times 7 squared minus 28 times 7. Yep, that goes in brackets, and then plus 87. No, it's minus 11. Minus 11? Yes, that makes sense. Okay, why does it make sense? Because I can put it is negative down here. Okay, so if you look at it's your turning point. That's the word I'm looking for. Okay, so the smallest value that you will get is negative 11. But now you're probably thinking to yourself, yeah, but for this term here. Okay, see, I'm thinking to myself, but yeah, we have negative 22, negative 28, 18, 14. Okay, we're not looking at that. They're looking at this sequence up here. So the quadratic one, quadratic sequence. What is its smallest value going to be? It's going to be negative 11. After negative 11, which is the 7th term, so 1, 2, 3, 4, 5, 6, 7. So after the 7th term, the 8th term, it's then going to increase again. So your numbers are going to start climbing. Okay, all right. So that's how 2.2 is done. Okay. Let's see, anything after that? There's a 2.3, yes. So 2.3 says consider k is added. Consider constant k is added to Tn such that all of the terms in the quadratic number pattern become positive. Determine the value of k. Oh, okay. So what is that asking? We'll squeeze it on the side there. Essentially what it's asking, if we draw a line, if I take my number pattern, Tn equals to 2n squared minus 28n plus 87. If I add k on, what should k be so that all my terms become positive? Okay, so every single term thereafter becomes positive. Now let's just think about it again. Okay, so let's think about our number pattern and what it represents. So in the previous question, we just found that the turning point of this thing happens in the 7th term. So at 7, at negative 11. Okay, so let's think about it. I want all my terms that follow this to be positive. Okay, this is not drawn to scale. Why? Because my cutting point is at positive 87. So let's draw this to make it look a little bit better. Okay, that's quite a big graph. So I'm cutting the y-axis here at 87. Okay, which means that my turning point was at negative 11. So in comparison, it is really close here, negative 11. Okay, so it's going to probably look something like that. Okay, if we're going to x intercepts here, just bear with me. So we want equation mode, so 5. Then we want the third one, and no, not the third one, the second one. So 5, and then we are solving, yes, the third one, sorry, and then we have 2 minus 28, and then 87. So if we go and solve that, the first intercept is here at 9, and then one is at, that one will be 4, and this is 9. Okay, and then between is 7, and we have the turning point down there. Okay, so if we look here, after my turning point, so everything's coming down here, so it's decreasing, 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 and after my turning point, I then have an increase in my function, and that's essentially what we're looking for. When will this start becoming positive values again? So the question says, consider a constant k is added to Tn such that all of the terms of the quadratic number pattern become positive. So my lowest point is -11. Okay, that's my turning point. So I want everything here to be positive, meaning what? Nothing should be below the x-axis, okay, or the n-axis in this term because it's Tn. So I've got to shift this whole graph up by 11 units. Okay, but more than 11 units because it needs to be strictly greater or always positive. So I need to now shift this up so that it looks something like this. So what should the minimum value of k be, or what should it be just greater than? It should be greater than 11 units because I want to get rid of this gap over here, those 11 units over there. So we're going to have that k must be greater than 11. So then we're going to have Tn equals to 2n squared minus 28n plus 87 plus 11, which means we'll get 2n squared minus 28n. Okay, and then now we'll have 98. Okay, so your turning point will still be at 7, but if you go and plug 7 into here now, you'll see that your value is definitely greater than 0. Okay, so we can do that quickly. So if we go 1, so we'll have 2 times 7 squared minus 28 times 7 plus 98 gives me 0. Okay, so now the turning point is on there, but this the pointer goes, the minute I go slightly bigger, so let's make this 99. So I move it 12 units up, we can see all my points are going to then be greater than 0. Okay, so it's just how to interpret that question. Okay, so I've done a sequence and series question. I've done a graphs function, which include a little bit of calculus as well. What's the next thing that you guys want to look at? So I want to hear from you guys now what you want to look at. So please let me know. Or if you have a question from a different past paper that you would like me to go over, then by all means, please just let me know what paper it is and yeah, what paper it is and what question it is, and then we can have a look at it. Okay, so I'm going to take about a 2-minute break, just catch my breath again, have something to drink, and then I'll continue with the next one. Yeah. So we haven't had the biggest turnout today, so take it everyone's probably watching other videos and this and that. Also want to know from you guys, do these stream? Okay, well, I think this is the first one. No, I did one. I'll not do one in the beginning of the year. Let me have a look quickly. I'm sure I did one in the beginning of the year. I must have done one in the beginning of the year. Let's go have a look. Calculus optimization. Okay, cool. We can have a look at one of those. Thank you for the input. When did I do this one? Yeah, this one I did at the beginning of the year. When did I do this one? Where's the date on it? Oh, 4 months ago. Yeah, I remember doing the live stream. Okay, so let's have a look at the optimization question then. I think I'll stick with the same paper. Let me just have a look at its optimization question. Okay, so actually quite a nice optimization question, this paper. So we're doing the Eastern Cape again. So Eastern Cape 2022 mock exam. Okay, which can be found on the link in the chat. Okay, I've probably said that about 100 times now. Okay, cool. So let's have it. So it says the diagram below shows a rectangle. Okay, so let me draw the diagram. So we've got the following diagram like such. Yep. And then we've got a rectangle that sits in over here. And they give us the equation of this line. It is y equals negative 3x plus 9. Okay. And this is A, B, C, and O. Okay. So they say the diagram below shows a rectangle O, A, B, C, where B lies on a straight line given by this of y equals to negative 3x plus 9. Okay, so that's your x-axis. And then this is shaded over here. Okay. Then C lies on the x-axis and A lies on the y-axis. Okay, so they're just telling me that that's y-intercept and that's an x-intercept. Okay, so notice that something's happening here. Oh, the Northwest 2022 September paper. Okay, let me have a look at that one then for you, and then I can come back to this one. Okay, so we want the Northwest 2022 September paper. Let's have a look at its optimization problem. Just waiting for the paper to load. Okay. Okay, so we'll come back to this one and put that aside. So we are going to look at the Northwest 2022 mock paper. Okay, let's have a look at its optimization question. Okay, so question 9, I'm taking you're looking at question 9. Okay, so we're looking at question 9. Okay, so let's just draw the diagram. So they give us the following over there. They've given us, oh, I've seen this question. Yeah, it's a very nice question. So a hill with a bar on it, and then there's T, this is H, okay, this is P, and then we've got S down here, and then we've got this dotted line that runs through P, up like that, and then we've got theta over here. Okay, so they say here that that's X and that is Y. Okay, so they give us that H of X is equal to minus X squared plus 4X minus 3. Okay, for the interval 1, X and 3. Okay, which means we know that this point here is 1. We know this point here is 3. Okay, because that's the only point of the graph is defined. Okay, P lies on the hill. Okay, then they tell us that the point T. Okay, so let's just read the whole thing. So it says, soldiers shoot at a fixed target TQ on the crest of a hill. The height of the hill is represented by that. Okay, so we can calculate this height over here. That's just your turning point. Okay, we want that height over there. We calculate turning point. And then they say P lies on it. So it says write down the expression of the gradient of the hill in terms of X. Okay, so we want the gradient of the hill. 9.1, we want of the hill. Okay, which means what? Okay, we want the gradient of the function. So essentially we want the derivative of the function. Okay, so let's have a look. Okay, so sorry, I've got a massive headache at the moment. So we want the gradient of the hill. We want how steep it is. So we are going to say h of x, which equals negative x squared plus 4x minus 3. And the gradient, so remember gradients always change in y over change in x, but now we're dealing with calculus, so the delta, and because it's no longer a straight line, it's not linear, we then call it a derivative. So dy dx of my function. So in this case, it's essentially dh of x over dy. I'm talking nonsense. Dx. This is y. Okay, so what do we then end up with? We end up with h prime of x equals to 2 times 1 is 2, so minus 2x. 2 minus 1 is 1. Plus 1 times 4 is 4. Minus 1 is then 0, so we just end up with that expression. Okay, so now I've got the expression for the gradient of the hill, how steep it is. That's essentially what it's asking. Okay, so let's see, what do we actually have to optimize here? So question 9.2, which is your optimization part, which counts 6 marks. So 9.2 says, what is the smallest angle theta that the soldiers, not shoulders, I keep soldiers, can aim to shoot at the target? Okay, so essentially is how close, or what's the smallest angle of theta? Okay, so that they can shoot. So essentially what we've got to do is we've got to move back in order to find how small can this angle be. Because obviously if I have an angle like this, you can see this is going to be very small. And if I keep moving back this way, I'm going to have a even smaller angle over here. Okay, so we want to know what's the smallest angle that they can shoot at in order to get that. Okay, why do we need why did question 1 ask us to find the gradient? Well, let's think about it. The gradient, which is given as the change in y over change in x, which is the derivative, okay, can also be expressed in terms of trigonometric functions. Okay, so what do we know that the change in y over the change in x is equal to which trigonometric? Okay, is it sine theta, cos theta, or tan theta? So you let me know quickly. I want to hear from you guys. Which trigonometric function is it? Sine, cos, or tan? Can get you guys involved in the question as well. Otherwise, I just sit here talking non-stop for the next hour. Okay, so let me know. Change in y over change in x represents which trigonometric function? Let me change. Let me stop this. Okay, let's see. Anyone? Everyone a bit too shy to talk or to type a message or not subscribed? Okay, remember if you want to type in the chat, I need you to be at least subscribed to the channel. Okay, so if you chose tan, you're correct. Okay, so we need a relationship between the gradient and theta. So we know that the change in y of change in x is equal to tan theta. And we know that the change in y over the change in x is essentially equal to my gradient. So what we actually have is we have h prime of x, equals to tan theta, which gives me what? Minus 2x plus 4 equals tan of theta. But now what happens? We have a theta value and we have an x value. So does anyone know how to determine that x value? Yeah, well, let's have a look. The way that they've drawn it, or given it, is at where it sits at the moment. Okay, it touches the graph at P. Okay, so if I want to make this smaller, does everyone agree that I need to move P towards the top of the function or to the top of the hill by moving this back? So if I move this back, okay, P essentially has to move. Okay, but P still got to stay in contact with the graph. So if we zoom in, here's my target, and there is P. So as we have it at the moment, if we shoot, we are going to hit the hill, okay, and then go up. So we can skim the hill. This is P. But I want to be able to hit the target. Okay, I see there's quite a delay in the chat. I wonder why the delay is that bad. Let me see here quickly. I think that's in. Oh, here we go. Message delay. How long do you want the participants to wait between sending messages? No, we don't want to wait them to send message. Let's change that to 5. Okay, so yeah, you're correct there with send a message every 5 seconds. Okay, all right. Okay, so getting back to where we were. If I want to change this angle, I need to move S essentially back. Okay, so if we look at it this way, if here's the top of my hill, the top of the pen's my hill, okay, yeah, we're going to have a very large angle. But as I start moving it away, what's essentially happening? Okay, it's going to get smaller and smaller with the x-axis. So if we have, yeah, let's do this here. Okay, so here's my x-axis, the top of the page. So if I'm very close, I'm shooting at a very high angle, okay, which you don't want to really do, okay? For those of you that take physics, if you're shooting at a very high angle, then gravity is playing a very big role on it, okay? or essentially you're shooting directly at gravity. So what we want to do is we want to open this angle and we want to bring it down. So essentially what we want to do is we want to make this angle small. Can you see it's getting smaller and smaller? So if I take it further and further back, I can drop this angle. So now I'm off the page, off the screen, but I can now make this angle extremely small over here. And that's essentially what we want to do. So we're going to move P all the way up to our, should ring a bell, turning point. Okay, so that's essentially what you got to go and do. You need to also find your turning point. Okay, so that's where your marks come in, because now you got to go and find the turning point of the graph. Or what you can do is you can find the gradient. Okay, so we have the gradient equals to this over here. And then essentially what you want to go find is you want to find where sorry, I had a braid lag there. So yeah, okay, so we want to find where this angle is the smallest, but we want to move that back so we can find the smallest possible angle over here. So my intuition is essentially what you want to do is you need to move your turning point up, or you need to move P up to the turning point, because as we start opening this up, we're going to be touching the graph closer and closer. Obviously, we can't now touch, you can't have it running like that, because that means you are parallel with it. You need to still be on the ground line here. Okay, but we could get very close to it. Okay. So let's just see what they did here in the question. Yeah, okay, so remember earlier on we spoke about the turning point of a graph, and we then have this b squared minus 4ac value that tells us where the turning point is. Okay, so when this equals to 0, then we end up with the turning point. So this is essentially called delta. Okay, so we would then want to go and find where this is equal to 0 so that we can then work out our turning point. Let me just see exactly what they've done here. Because how I would do it is I'd find my turning point using this function over here. So I would find TP equals to negative b over 2a, which essentially equals to, let's see if the way I do it gives me the correct answer. 2 times negative 1, which then we end up with a value of that is 2. Yeah. So now that we have that, we can plug it into our function and we can go and find it. So therefore we're going to have negative 2 squared. So we're looking at h of 2 plus 4 times 2 minus 3. Okay. Which then gives you, let's see over there. So we have negative 2 squared plus 4 times 2 minus 3. So we have an answer of 1. No, that's not possible. If the 1, yes, sorry. I keep confusing it. We add 2 over here, which means this value here is 1. Okay, so the height here is 1. Okay, we can also do the derivative, take the derivative, and then find its maximum point. You'll get back to the same answer. Okay, so now that I have that value over there, let's have a look at something. If I say, we say negative 2 times 1 plus 4 equals tan theta, you're essentially going to get, this is going to equal to 2 equals to tan theta. And what is tan of 2? Gives you 63. Okay. So therefore we have theta equals to 63.43, and then okay, very close, but quite far off. Okay, so my value that I get is 26, but the answer is supposed to be 28.9. Okay, so obviously the way I'm going about it is not how we're supposed to do it. Okay, so let's see what they've done here. So they have the gradient divided by x. Sorry, I'm just having a look at this at the memo quickly just to see exactly what they've done. Okay, so in the memo they've done this. I'm just trying to figure out why. So they have negative x squared plus 4x minus 3 divided by x equals 2 my gradient minus 2x plus 4. Now, why do they have it that way? Essentially, this is h of x. So we have h of x divided by x equals to, this is h prime of x. So essentially what they're saying is that h of x equals to x times h prime of x. So where are they getting that from? Oh, me being stupid. Okay, so let's have a look here. S, okay, so obviously S is staying stationary. Let me just read the question again and say if S must stay stationary. Let me just go back up because then I figured out where I'm getting confused. Okay, so S has to stay stationary. So my bad about that. I sent you on a loop that we didn't have to take. Okay, if S could move, then yes, we would end up with what I've done here, and that would be an easier way of doing it. Okay, so essentially, let me just redraw this again. Okay, so we have the following over here. Okay, S has to stay where it is. There's our target, and we're shooting up at the target. There is P, and this is S, that's 0, 0, and there's P. Okay, so what are they asking us? So we need to find theta, which means we need the gradient. Why? Because we know that tan of theta equals change in y over change in x, which also equals the derivative of function f prime of x. Okay, so what you needed to realize is we need to take the gradient between s and p. Okay, so we have s is given as 0, 0, and we have p is given as an x value, okay, some x value over here, multiplied by f of, or h at that x value, which is given as h of x. So minus x squared plus 4x minus 3. Okay, so for a given x value, we have a given y value. So this is x and that's y. Okay. All right, so what we do is we find the gradient. So we say the change in y over the change in x must equal to theta. Okay, so how do we go and we calculate that? Well, what we do is we take our 2 points and we minus them. So p minus s. So we're going to have minus x squared plus 4x minus 3 minus 0 divided by x2, which is x minus 0, must equal to my second derivative, which equals to that, essentially. So what do they want us to do? We then have, what was my second derivative? Let's find the second derivative. It was minus 2x plus 4. So this is equal to minus 2x plus 4. Why? Because tan of theta equals h prime of x. So I was on the right track. Okay, I just didn't substitute in the right things at the right time. So now we have the following expression: minus x squared plus 4x minus 3 divided by x equals minus 2x plus 4. Aha, this makes sense now. Okay, now that we have this, okay, we can solve for x. So I'm going to multiply that across, so minus x squared plus 4x minus 3 equals minus 2x squared plus 4x. Okay, so you can see plus 4x and plus 4x on each side, so that cancels out. Okay, which means we then have, take that over, it becomes positive, so negative 1 plus 2, so you end up with x squared minus 3 equals 0. Okay, so essentially, yes, it is a difference of two squares. It's just not perfect squares. So we have x minus root 3, x plus root 3, okay, equals 0. So therefore, x equals root 3, or x equals minus root 3. So now which one do we use? Because essentially, let's have a look. Root 3 is equal to 1.73. Okay, so this is 1.73, and if we say negative, you end up with negative 1.73. Okay, so what do we do from here? Okay, so we've got now the value of x, so essentially we can now solve for our gradient. Okay, I'll get to functions. So if you can let me know, if you can let me know what question, so from what past paper that you have a problem with, I can then do it after this question. So I just want to finish this one. Okay. So what essentially we have now is we have the x value, but we need the gradient. Okay, so this we can't now essentially go and substitute in here in order to solve, because at the moment we've just got an x value, but now we need the gradient value. Okay, so my gradient m equals to h prime of x. Aha, so we've got an x value. So we can go h of 1.73, or you can write square root of 3. Now, which one are we going to use? Negative or positive? Well, let's see if they give us the same answer. So this is going to then be minus 2 root 3 plus 4. So let's have a look there. Now we're going to use the positive one. It makes sense. Why? Doesn't make sense. No. We'll have a look. So 2 open square root 3. Okay. Plus 4. I need a negative in front. That gives me an answer of 0.54. And let's do it if I put in the negative here. 7. Okay, so it makes sense that we use the positive one. Why? Because if we use the negative one, it's the negative times negative, it then gives you a positive, which means then we have positive plus positive, it then gives you a big number. So you always want to use then the positive number here. So then negative times positive is negative, plus the 4 gives you a little number. Okay. All right. So now we've got the value of m. So m equals delta y over delta x, which equals tan of theta. Okay, now we can solve for theta because we have 0.54 equals to tan theta. So therefore, if we find theta, we are then going to have shift tan 0.54, which gives you an answer of 28.37 degrees. Okay, so quite a nice question here. They wanted to test whether you see that tan equals your gradient, which equals the change in derivative, which can also be written in terms of your function. Okay, remember, this is just the input, and that is always your function. Your y value is always your function. Okay, so we first solve for x, for the gradient. Once we have the gradient, we know that the gradient equals to the derivative. Okay, so m equals to that. Okay, so then we can say that m equals to that. We can then solve for m because we have an expression now where we can plug x in, and then m equals to 0.54. And after that, we then substitute that into this expression here, and we solve for theta. Okay, so whenever you have theta and you have to relate it back to a gradient, you always use tan, because tan is always change in y over change in x. Yeah. So I think I'm pronouncing it right. Siatemba, if you can let me know if I've explained the question, if it makes a little bit more sense to you, if you figured out why the memo was saying what it was. So if you could just let me know about that, and then I can move on to a functions question for the Sejo. Okay. Lucejo, if you can please give me a question, or just let me know if I can pick a random functions question to do. Is there something specific in functions you're struggling with? So is it a specific, let's see, cubic functions, please. Okay, so I need to find a cubic function question. Let's see if this paper had a cubic functions question. Okay, I'm at the moment looking at the Northwest paper for those of you who have just joined. Let's see, is there a cubic function question? There is. So determine the equation f double prime. Write down the x values for the point of intersection. Lucejo, if you're still in the chat, can you just let me know if there's a specific paper you want me to do, or if I can just pick a random cubic function question and we have a look at that. As far as I know, cubic functions are always related to your differential or calculus part of the paper. Okay, so I think let's just then have a look at question 8 of this one. So question 8 is the cubic function. Okay, so let's just run over what a cubic function looks like. Okay, so a basic cubic function, if you have f of x equals x cubed, it's going to look like a tan function. Okay, so it looks something like that. And then as we start adding terms, so ax bx squared plus cx plus d, as you start adding it, then the function starts to look something like this. Okay, depending on what the values are, what's missing, and so on, you then end up with two turning points. Okay, you end up if a is positive. Okay, if a is positive, then you'll always end up with it looking like this. If a is negative, so negative a, then you end up with something that looks like that. So for positive a, you'll always have increasing, decreasing, and then increasing. Negative a, you'll have decreasing, increasing, decreasing. So negative a always gives you two decreasing points. Okay. Sorry, I keep forgetting that the chat for some reason is on a very slow reply time. I need to find that setting so that the questions come, or the chat comes through a little bit quicker. Or maybe I'm just on the wrong setting. Let's have a look here. Live chat. Nope. Let me have a look here. Okay. Let's have a look at this question then. So we've got about 20 minutes left in the stream. Okay, so I'll get through this question and then we'll see if we have time for another one. Okay. So for cubic functions, factorizing them, you can do that on your calculator. Otherwise, you have to do long division. That's probably the easiest way to do it, or at least the way I know. I know there's a whole bunch of jipper ways to do it, or easy, quick ways to do it. But if you're going to factorize a cubic function, you find where the cubic function is equal to 0. So you check. Normally, it's the ones that they give you. You check -2, -1, 0, 1, and 2. You check those values. You check where f of x equals 0 at those values, and then you end up with your first factor. So let's say your factor is 1, so therefore it's x minus 1, and then you do long division of your entire polynomial, x cubed plus so on and so on, and then you do the long division. That's probably your safest bet to do it this way, to do long division. I do know it takes time. Otherwise, what you do is, if you have a calculator like mine, you go to equations, so 3, no, talking nonsense, equations, which is 5, and then right at the bottom here, option 4, let me just show you over there. Option 4, you can then factorize cubic functions. Okay. So if I choose option 4, and let's say we have, sure, now I've got to think of one out the top of my head. So one, let's say B is 3, C is 5, and D is -2. Okay. If we then factorize that, x of 1 is 0.3, x of 2 is a composite number, it's an imaginary number, and then x of 3 is also an imaginary number. So this one only, or my example only has one real root. Okay, but anyway, that's deviating off of what we're doing. If we look at the cubic function, if we want to solve the cubic function, solve A, solve B, solve C, and solve D, what they'll tend to do is they'll tell you that f prime okay, well, having last year's question paper, it's question 7. Okay, so I take it is it last year's prelim paper? For which province? Or is it last year's paper? Let's have a look. As in the final paper. So, I don't know why there's a delay so bad. Okay, let's see. Last year's question 7, 5, 6. Oh, I can use the calculator to factorize. Okay, so let me repeat that again. Okay, I know the screen is blurry. Let me see. There we go. Okay, so if I clear, come on. 1. Gauteng question paper, please. Okay, all right. I'll get to the last year's Gauteng question paper. Okay, so if you want to factorize using your calculator, okay, what you do is you go mode. Okay, mine is number 5. You go find equations. Okay, I know that the black Casios don't have all the settings that this one has. Okay, so this one I can factor straight lines. Then I can factor a straight line again, or different function that's equal to something. I can factorize a parabola, and I can factorize a cubic function. So if you want to factorize the cubic function, you choose option 4. From there, you go and you plug in your A value, so whatever A is. If A is 1, you plug it in. If B is 5, plug it in. C is -3, and then your y-intercept is, let's say, I don't know, 8, whatever your function is. And then you push equals, okay, you put everything in and then equal sign and it calculates it for you. So there's x1, okay, you push equal sign again, x2 and x3. Okay, but obviously these values are going to give you imaginary numbers. So yeah, the equation or the cubic functions they give you won't have imaginary numbers because you guys don't do imaginary numbers. Okay, if you want to factorize a parabola, you do the same thing. So mode equation, which is 5 for me. I think on the black Casios it's number 3 because you guys you've got only 3 options. I think the one is stats mode and then the other one is equations, and then you'll choose number 3 and then you fill in A, whatever A is, you fill in B's value 5 and then you fill in C's value, so -6. And then also again it will factorize it for you. There's your first x value, there's your second x value, there's your maximum, your minimum, and there we go. So essentially it gives you your turning points as well, and so on. Okay, so that's how you use your calculator. But the long way is you can do long division for cubic functions. So if you have a cubic function, you test -2, so where x equals -2, you check if it gives you 0, -1, so on. The one that does give you 0, then essentially you have x equals to, let's say, 1. So your first factor is x minus 1 equals 0, and then you divide your polynomial long division with x equals to 1. Okay, so that's how you do it the long division way. But let's go to Gauteng, last year's Gauteng question 7. So let me just find the paper quickly. The mock exam. Let me have a look at question 7. Yeah. Possible answers. No, we want the question paper in English. Okay, so I've got the paper open, so I'm going to question 7, 5, 6. The Gauteng paper question 7 is, or at least the one I have here, is your financial maths. And I don't think that's the one you're asking me. Is it maybe question 9, Lesego? Or if you can let me know where you got the paper from. If you got the paper from the website that's in the chat here, test paper, so I'll copy the link again and I'll paste it. For those of you who have just joined, then at least you have it. Wait, it's not. I'm having last year question paper and it's question 7. Gauteng question paper, please. Last year's Gauteng mock exam. That's the one that I have open. And question 7 is not a parabola. Was it a department paper that you're looking at, Lesego, or is it a internal paper that you're looking at? Because I don't have access to all the school's internal papers. I've only got the department's paper. And in the Gauteng, no, you can email me the question. So if you go to I'll get the email for you now. Then you can send me an email. Let me paste the email address. Then you can send me the question via my email. So if you send me a photo of the question, then I can open it up and have a look at it, and then I can give you feedback on it. But the last year's Gauteng paper, the only one that I can find, question 7 was financial maths. Okay, remember the structure of your paper is always algebra, then at least 2 questions on sequences and series. Then you start with your hyperbolas and exponential functions. Okay, it's normally in the sense of where they don't give you the graph and then you have to figure things out. So there's always 3 graph questions. It's always hyperbolas and parabolas, or hyperbolas, then exponential functions. Then you do your difficult questions with graphs such as parabolas, straight lines, using calculus, and that goes from question, what's that? That's 1, 2, 3. So 4 to 6 or 4 to 7, 4 to 6, and then question 7 is normally financial maths. Question 8 starts with calculus. Question 9, calculus again. Question 10 is your optimization, and then question 11 is always probability. Okay, so let me check if you've sent me the paper, and then I can have a look at it. So also let me know once you've sent me the email, then I can have a look at it. Okay. Any other questions from anyone? I was going to end the stream now at 8, but because we started later, I'll make up for the time that I started later due to the technical difficulties. So I'll push the stream for another 15 to 20 minutes or so. So if anyone else has any questions regarding anything from Maths Paper 1, something they want me to explain or something like that, then please let me know and I can go over that. I know you guys are writing tomorrow, so I know it is on your prelims, but treat your prelims like your finals. That's a good indication to see where you are with preparation. So make sure you clarify things now so that you don't have to sit the night before you write your final paper trying to clarify anything. Let's have a look here. Anything there? Nope. I haven't had the email come through yet, so let me know once the question comes through and I can have a look at it. Okay, I'm going to find a question for now for cubic functions, and then once your question comes through, then I can have a look at that. Okay, so let me actually have a look here at which one's this? This is the Gauteng. No. Okay, so this is a Gauteng paper. It's last year's Gauteng mock exam or preparation exam. So if you are looking at the website for test papers, this is the one I'm looking at the moment. September 2023, Limpopo, functions, calculus, and number patterns. Okay, I don't think I'll get through everything before the end of the stream, but I can have a look at 2023, Limpopo, September. You mean 2022, because September papers hasn't come out yet. You guys are writing for 2023. So I'm taking it you're talking about the 2022 Limpopo question. So let's have a look there. I'll open it up quickly. Okay, just a reminder, there is a video, an hour-long video on algebra if you guys need it for tomorrow's paper on my channel as well. So let me just quickly go open this paper. Okay, I don't have anything in my email inbox yet from regarding anything, so refresh. Okay. The Limpopo paper. Okay, it's open. So, can you show us how to determine the value of a variable when it only has one or two positive roots? Okay, so if you're determining whether your roots are positive, I'll run over that quickly, and then I'll have a look at Katlejo. I'll have a look at the Limpopo paper. So when we're doing positive roots for function, whenever they ask that, so find positive roots. Okay, essentially what we are looking at is your quadratic formula. So x equals negative b plus minus the square root of b squared minus 4ac all over 2a. Okay, if we want no roots, so no real roots, then essentially we're looking at your delta. They always call it delta, but essentially this here is how far you're sitting from your turning point. Because when this is 0, you just have your turning point. I explained it earlier on. Okay, so this here tells me how far I am from my axis of symmetry, which will then tell me where I'm cutting the x-axis. Okay, in calculus, so can you show us how to determine the values of variables when it only has one or two positive roots in calculus? Oh, okay. So you're talking about cubic functions. So you want to determine whether the cubic function is going to have two positive roots, or do you guys do that? Because that is a form of numerical analysis. But if we look at a cubic function, let me have a look. Okay. So if we look at a cubic function, the best way to essentially explain it, whether if it has how many roots it has. Cuboid graphs. In cubic graphs. Okay, but if you have a look here, okay, so if we want to determine from our whether our function how many roots it has, okay, let's have a look. What you want to first do is find your critical points, which essentially means you have to factorize. So when you factorize, okay, you then find your critical points. We would find that one, and that one, and then from there you can determine how many positive or how many negative. If you want to determine whether there is going to be real roots or non-real roots, essentially what you want to do is you want to find your two turning points. Now, how do you find the turning points of a graph? So the easiest way to check whether we'll have 1, 2, or 3 intercepts is you want to find your turning point. The reason why I say that, if you look at the following over here, if your graph looks something like this, okay, you can see we're only going to have one turning point. If your graph looks something like this, we're only going to have one intercept. Determine the value of p for which f of p has only one root. Okay, so that's essentially what I'm explaining over here. Okay, so if your graph looks something like this, you can see we're only going to have one root. If it looks something like this, we're going to only have one root over there. Okay, so how do I determine this? Okay, well, the quickest way to essentially look at it, okay, if I have to explain it using calculus in a simple manner, okay, because this is how I understand it. What you want to do is you want to find the derivative of your cubic function. So d dx of f of x. So let's say you have x cubed plus x squared, or 2x squared minus 7x plus 10. Okay, whatever your function is. What you do is you take the derivative of. Now, the derivative is always going to give you a parabolic function. Okay, so f prime of x is 3x plus 14x minus 7. Okay, and you want to set that equal to 0. Why? Because you want to find your turning points. Okay, once you have your turning points, okay, you can find exactly where they are. Okay, so you then solve that, you find your turning point 1. So turning point 1, you find the x value. Turning point 2, you y value. Okay, if both of them are positive y values, you're only going to have one x-intercept. Okay, regardless of if a is positive or negative. So if a looks like that, then you're also only going to have one x-intercept. If both of them are negative y values, you're also only going to have one. So essentially what you want to do is you need to shift the graph accordingly so that if you have one of them above and one below, then you know you'll have multiple ones. Or if one of your turning points sits on the graph on the x-axis, you know you'll then have two x-intercepts. But determining the number of cuts you can look at using your derivatives. Okay, so in this case, determine the value of p. Determine the value of p for which f of p or f of x will equal p. Okay, so that's just finding a y value, or only as one root. So essentially, what it will be f of x plus p only has one root. In that case, what you do is you find your derivative, you find your first derivative, okay? You set it equal to 0, you find your two turning points. Let's say this one is -1 and that one there, the x value is +5. And when you substitute that back into the function, you get f of -1 is, I don't know, 7, and f of 5 is equal to -3. Okay, then essentially what you have is your graph will look something like this. You're going to have 7 up there at -1 and -3 over there at 5. So your function is going to look something like this. Something like that. Okay, so now how do I get this to only have one x-intercept? If I continue shifting this up, I'm still going to have 2. But I know that if I shift this down, we're always still going to have this. So essentially what you want to do is you want to take this and take it below the axis. So you want to end up with a graph that looks something like this. So you start here, we said that was 7. Okay, you want to move it a minimum of 7 units down, because then we below the axis, and then we only have one cut. Okay, so I hope that makes sense there with that one over there. Okay, so everything works off taking the derivative. It doesn't help taking the second derivative. Why? The cubic function, its first derivative, so if this is f of x, f prime of x is then a parabola, and f double prime of x is a straight line. So taking the second derivative tells you nothing about your x-intercepts, you always want to take this one over here. Okay, so you always want to take the parabola. Okay, so that's regarding that. Okay, for cubic functions. If it's for a parabola, then all you want to do is shift the parabola up and down accordingly. Okay, if a parabola only has one, or it will only have one x-intercept when the turning point is on the x-axis. Okay. I don't think I'm going to get through all of the functions, calculus, and number patterns question for Limpopo 2022. I'm definitely not going to have enough time for that, but maybe let's have a look at the functions question. Let's check if I have an email that's come through from Lesejo. Lesejo, if you send me an email, then we can have a look at the question, but I need you to send me the email like in the next 2 minutes. Otherwise, I can't go over that question for you because I am ending the stream in about 15 minutes time. So okay, so let's have a look at the Limpopo functions question. I think I'll look at question 4 then from the Limpopo paper. Okay, so question 4 from, I'm looking at the Limpopo. It's only a pleasure, Michael. I'm glad I could help you. Good luck with the studies for tomorrow. I hope the stream's out there and you can have answered some of your questions and it makes it easy for you tomorrow. So good luck with the remaining studies. Okay, so as I was saying, the Limpopo paper, so I'm looking at Limpopo National Senior Certificate, grade 12. But it says here, August 2022, the preliminary or pre-trial examination. Okay, so if you go to test papers, so the link that I've sent now twice in the chat, and you click on that and you go to the Limpopo paper. It is the Limpopo August paper. I'm going to look at question 4 from that. It is a parabola and a straight line, and then I think we will conclude on that. Okay. So it shows you the following figure. 2022 mock paper. Okay, so we have the following figure over here. We have our y-axis and our x-axis over here. Y, x, okay, and then we have a parabola, which then cuts down there, and we have a straight line, which that straight line runs like such. I just got to get this drawing right. Okay, so that's G, and then this is F. Okay, and then they give us this point here is C, that's B. P is your turning point. They give you a point here, M. They come down, yeah. So that this is perpendicular, that's N. This is A, D. So D is talking about that point over there. And then E is over here. Okay, and then they give you the functions. So we have, let me do it over here. Let's do it down here. So f of x equals to minus x plus 7 squared. Okay, plus 25. And then we have g of x equals to x plus 2. So we know already that d is going to have a value of 2 because of our straight line. Okay. Then it says determine the coordinate of P, the turning point of the parabola. Okay. So we want the turning point of the parabola. So turning point, there's two ways we can do it. We can use turning point equals to negative b over 2a, but in this case we have the equation set up in the form of x plus p squared plus q. Okay, so there's no b value in this case. And you guys don't do the chain rule, so I'm just going to sort everything out here. It's easier. Okay, so let's rewrite f of x in this way. So it's going to be negative, let's see, that's x squared, so two of those brackets, then plus 14x, and then plus 49, plus 25. So substitute the negative in, that's negative x squared minus 14x minus 49 plus 25. So we end up with an answer of minus x squared minus 14x. And then 49, that's 24, yes. So minus 24. Now we can solve turning point. Okay, so my turning point is going to equal to negative 14 divided by, divided by 2 times negative 1, which then gives you, let's see, that's positive, negative, so that's going to give you negative 7. Okay. Now that we have that, we can substitute that back into the function. So essentially what we have here is x of negative 7. That makes it quite simple. Your turning point is at 25. Okay, so x of 7 is going to equal to negative 7 plus 7 squared plus 25. So what do we notice? The turning point is where this is essentially equal to 0, yeah, and then that point over there. Okay, I didn't actually even know that. So you're going to get this equals to 0, so you just end up with plus 25. So your turning point for P is going to then be negative 7 and 25. Okay, so that's the turning point. Then it says the length of DE. So we want this length here. Okay, 2 marks, that's pretty straightforward. Nothing too difficult over there. So we want 4.1.2. Okay, we want the length of DE. Okay, so D is a y-intercept, E is a y-intercept. So now we have the y-intercept for the function of f. So we know that D's coordinate is 0 and 2. And we know E's coordinate is 0 and minus 24. So we take the difference between them. So it's going to be 2 minus 24, which is then going to give you minus 26. Okay, not too difficult with that one. And then 4.1.3 says the coordinate of C. So we've got to find the coordinate of C. Okay, now whenever you find the coordinate of C, you can see the two of them intersect each other, which means they both have the same x value and the exact same y value. Okay, so what do we then do? We equate the two equations equal to each other. So we're finding where f of x equals to g of x. Okay, so we equate the two equal to each other. So we have minus x squared minus 14x minus 24 is equal to g of x, which is x plus 2. Okay, so there's g of x. Okay, and then we solve for x. So therefore we have minus x squared. Take that over, it's minus 15x. Take that over is minus 26 equals 0. Divide out by a negative to make life easy. So x squared plus 15x plus 26 equals 0. Okay, and then I'm going to use my calculator to factorize it so I can show you. So we go, I'll get there. So we go mode, then we go equation, so 5, and then we choose number 3. Okay, and then we just plug everything in. So 1, 15, 26 equals, so we know that the first x value is going to be at -2, and the second x value is going to be x2 equals -13. Now, it doesn't make sense that c's coordinate takes on the value of -2. It doesn't make sense for that. Why? Because it's sitting too far from the y-axis. So therefore, c's value is definitely going to have an x value of -13. Now we go find the corresponding y value by plugging it back into any one of the functions. It doesn't matter because they both intercept there. So I'm going to use g of x. It's the easier one. Okay, so all we then do is we say -13 plus 2, which then gives you -13 plus 2 is -11. Okay. Let me just go back to normal mode there. So -13 plus 2 is -11. And then that gives you c's coordinate. Okay. Then they ask you the graph of G is shifted up to pass B. The graph of G. The graph of G, yes, yeah, shifted up so that it's past B. So it's going to sit somewhere up here. Okay, so past the coordinate of B. Determine the equation of determine the equation of the shifted graph G. The graph of G is shifted up to pass at B. So the graph is running through there. Okay, so now it's running through that point there. Find the equation of the new line passing through that point. So essentially we need to find the equation of the line running through there. Now, what you could do is, because the graph is just shifted up, okay, doesn't make sense that the gradient changes. Okay, so by moving it up, your gradient's still the same. So your gradient is still going to be 1. And then you can find, or what you can do is you have the coordinate of B, because we know the x-intercept. So we can find the x-intercept of B by factorizing our parabola. Okay, so f of x equals to -x squared minus 14x minus 24. Okay, and then if we go and we factorize that, you can use your calculator again. 5, so 3, and then we have -1, -14, and -24. So we end up with -2 and -12. Okay, so we have -2, -2 and 0, and the other one is -12 and 0. So it only makes sense that B takes on the form of -12 and 0. Okay, so now we've got that. We know that the gradient's going to stay the same, so m equals to 1. So therefore we have y equals to 1 x plus c, but we also have the coordinate over there. So essentially what we have there is we substitute those values in. So we have -12 equals 1, 0 plus c. So c equals -12. So you have y equals to x minus x should be a positive, plus 12, sorry. Okay. And that's how we go about doing that one. So then we end up with a plus 12 over there. Okay. You can also use the other one, y minus y1 equals m x minus x1. Okay, you can use that and you'll get to that equation over there. Okay. All right. And then the last one says the value of x for which the length of mn is a maximum in the domain where f is greater than g. Okay, so we essentially want to find where that is a maximum. So how do we go about solving that? Okay, so what you want to do is you always take the top function. So it's f of x minus g of x. Okay, and then if you solve for that, you can get your x coordinate. Okay. What happened now? Sorry, my paper disappeared. Let me just get the paper back quickly. Okay, so you're essentially finding you're finding this over here. Okay, so once we have this over here, we're going to end up with what was it? Was minus x squared minus 14x minus 24, and then we're minusing x plus 2. Okay, so we end up with minus x squared minus 15x minus 26, but we want to maximize that. So when we maximize, we take the derivative. Okay, so we set the derivative equal to 0, and then we solve. So we want to take dx of negative x squared minus 15x minus 26 equal to 0. Okay, and we'll take the derivative of that. We get minus 2x minus 15 equals to 0. Therefore, x equals to minus 7.5. Minus 7.5. Okay, take that over, divide by negative 2, you get minus 7.5. So now that you end up with that, they want to know what is, so mn is a maximum. Okay, so when is mn a maximum? Mn is a maximum when x equals to negative 7.5. Okay. All right. Or when mn is a distance of 7.5 units. 7.5 units from the y. So we want this x coordinate over here, which is 7.5, essentially what they're asking us. Okay. All right. Still didn't get the email. Okay, so let me just change the cameras and I can say goodbye to everyone and you guys can have a look at, I can look at you guys. Where is it? Where's my camera? Could you go? Here we go. So if I do this. Okay. Let me take this down so you guys are gonna stay awake. Let me do this. Okay, let me replace this here. So we'll put that one there. Okay, now you'll okay, so as I was saying, make sure that you guys get enough sleep tonight. Don't go writing the paper on 2 hours of work. It doesn't work so well. Make sure that you just read through your theory one more time before you go to bed tonight, especially for those questions I could ask. When are positive roots? When are negative roots? And so on and so on. Okay, you don't want to be caught up with a question like that because you're not understanding it, how the quadratic equation works. Okay, if you want extra videos, there are extra videos on my channel covering maths paper 1. Go look at June papers. Go look at the end of year paper if you want. Everything is there. So yeah, good luck with all the prep. Good luck with the paper tomorrow. And remember, it's never too late to have an OIC moment. Thanks, everyone.